Today's lesson we are going to discuss another type of transformation, and this one is called a dilation. Dilation is when you make a shape smaller or bigger. If you've ever been to the eye doctor and they shine the light in your eye, they're testing your pupil to see if it dilates, if it gets bigger or smaller appropriately. That's a good example of a real world situation of a dilation. Okay, now a scale factor is a number. It's a number that tells us how big or small shape will get. Okay? Now, scale factor, to figure out that scale factor, if it's not given to us, we take any number that is associated with the image, and we divide it by the same exact matching number from the pre-image. Okay? An enlargement is when it gets bigger, and the scale factor is always greater than 1, okay, if it's an enlargement. All right? A reduction is when it gets smaller. And for that, the scale factor will be less than 1, but greater than 0. Okay? And finally, scalar multiplication is when we take and we multiply everything by the scale factor. Okay, that's called scalar multiplication. Let's try some examples. Okay, our first example, we're going to graph the image of the figure using the transformation given. So this is telling us that we want a dilation of 2. So that means 2 is our scale factor. Okay? If the scale factor is greater than 1 here, I know this is going to be an enlargement. All right? So the first thing I'm going to do is I'm going to write down each point that's given. So C has coordinates 2, 2. D has coordinates -1, +1. And J has coordinates of +1, -1. Okay? So I'm going to apply the scale factor here. I'm going to multiply everything by 2. Each point I'm going to double. So that gives me my new C, which is C prime, would be 4, 4. I'll graph that. 4, 4 would be here. All right. D prime would be -2, +2. -2, +2 would be right here. That's D prime. And J prime would be +2, -2. All right, so I just multiplied all the points by 2 because that was the scale factor. +2, -2 would be right there. Now if I connect those, see if I can connect them pretty decently here, you can see that that original triangle, the pre-image, has doubled in size because the scale factor was 2. Okay, now we're going to do the same thing over here with number 2. This time it has a dilation of half, so the scale factor is half, which means this is going to be a reduction. Okay, I'm going to do the same thing. I'm going to take the original points. Let's take B. B is 0, 1. M is 4, 4. And N is 1, 0. Now I'm going to take each of these and I'm going to multiply them by half. Okay, or I'm going to divide by 2. That does the same thing. All right? So our new B, 0 stays as 0. 1 times half is half. So 0 half would be right there. That's B prime. M prime. 4 divided by 2 is 2, and again 4 divided by 2 is 2. So M prime is 2, 2, which is right there. There's M prime. And N prime would be half. Whoops, sorry, this should be a 2. Half of 1 is, again, half. Half of 0 is 0. So half 1 would be right there. So if I connect those, you can see that triangle has shrunk half the size because the scale factor was half. Okay, finally here we're not gonna worry about graphing it, but again we're gonna use scalar multiplication to find the image of this four-sided shape QRTW, and we're gonna dilate it with the center being the origin, and the first scale factor is going to be 1/3. Okay, so I know this is going to be a reduction because the scale factor is less than 1. So I'm going to arrange my points with what we call a matrix. Okay, so I'm going to organize my points in matrix form. So I'm going to take my 4 points here and arrange them. Try this again. QRTW. Arrange them with brackets. Okay, all of my x coordinates will go on top and all my y coordinates will go on the bottom. So I'm going to arrange these first. So Q is -3, 4. R is -2, -1. T is 3, 1, it looks like. 3, 1. And W is 3, 5. Alright, so first thing I'm going to do is, for number 3, I'm going to take that scale factor of third, okay? I'm going to multiply everything in it by that scale factor, third. Now multiplying by a third is the same thing as dividing by 3. Okay, so I'm going to get my new points, Q prime, R prime, T prime, and W prime. Okay, I'm going to arrange my answer in a matrix as well. So my x's are on top, my y's are on the bottom. I'm going to take each point divided by 3. So -3 divided by 3, that's -1. I'm going to go right across the top. -2 divided by 3, all right, is -2/3. 3 divided by 3 is +1. 3 divided by 3 is +1. Those are all my x coordinates. And I'm going to do the same thing with the y coordinates. Okay. 4 divided by 3 is 4/3. -1 divided by 3 is -1/3. That's a 3. 1 divided by 1/3 is, or 1 divided by 3 is 1/3, and 5 divided by 3 is 5/3. Okay? So that's our answer for number 3. Now if I plotted these points, that would make the original shape 1/3 the original size. Okay? Alright, now for the next example, what we're going to do is we're going to multiply everything by 5 in this case. So this is my scale factor of 5, which means this is an enlargement. Whoa. Okay, so for my new points here, I'm going to double prime these. Q double prime, R double prime, T double prime, and W double prime. X's go on top, Y's go on the bottom. All I'm going to do is multiply everything in this matrix, every point, every number, every coordinate by 5. So let's see. -3 times 5 is -15. -2 times 5 is -10. 3 times 5 is 15 for that one, and again 15 for this one. Alright, scale factor being greater than 1 is a lot easier than a fraction, as we can see. Let's do the y coordinates. Multiply everything down here by 5, that gives me 20, -5, +5, and 25. So if I graph this, obviously it would not fit on this graph, but it would be 5 times as big. All right, that's our lesson on dilations. So we talked about scale factor, what makes it a reduction, what makes it an enlargement. Okay, we graph dilations, and we also use some scalar multiplication with matrices. So I hope you got something out of the lesson.